Okay, so let's continue the photochemistry, organic photochemistry, cis-trans isomerism. Cis-trans isomerism takes place in 7 to 8 membered alpha beta unsaturated carbonyl compounds. Here I'm taking one, two, three, four, five, six, seven, eight membered alpha beta unsaturated carbonyl compound. This structure indicates that it is a cis one, and cis will be in equilibrium with the trans one when it is irradiated. So the trans one will have this structure. That means this is the priority group. Both the priority groups are in opposite direction. This is nothing but a bismuthine. This is also a trans one. I will with this I will go to the next slide. In the next slide, pi bond migration. So pi bond migration is possible for the alpha beta unsaturated carbonyl compound having gamma hydrogen. So pi bond migration possible for alpha beta unsaturated carbonyl having gamma hydrogen. So here a pi bond is migrated from alpha beta to beta gamma. So that means conjugated double bond is converted into isolated double bond. So obtained one is a beta gamma unsaturated carbonyl compound. So here I am taking an example. R can be alkyl or aryl group, and when it is in ground state, when it is irradiated with lambda max, a singlet is obtained, and the singlet when it intersystem crossing, it forms a triplet one. So in the triplet stage, the pi electrons are undergoing homolysis, forming a radical. That means forming a new pi bond here and a OH bond. Means enol and also a gamma beta gamma double bond, and then alpha carbonyl carbon double bond and OH bond, enol formation is there. Then enol gets converted into ketone. In this process, alpha beta double bond is converted into beta gamma double bond carbonyl compounds. I am taking one more example, alpha beta gamma. That means this double bond is moving from here to here. The product is this one. I will go to the next slide. In the next slide, here you can observe that two gamma hydrogens. This is one gamma hydrogen. This is another gamma hydrogen. But what is the important thing? This is the CH2 one and this is the CH3 one. So this CH2 one will be the weaker one. That's the reason here double bond formation, not on this carbon. So then here alpha beta gamma. So that means here there will be a double bond formation. So here I am taking one example. You have to write the mechanism for this. So this is again Norris type reactions. A cleavage occurs between the alpha carbon, more particularly more substituted carbon. Here there will be a cleavage and NO will react here. Insertion of NO. So obtained one is this one. Let us go to the next slide. In the next slide, I'm taking few more examples. So here a 10-member diketone I'm taking. So 10-member diketone is converted into a octanone. This is the cyclooctanone. How it is converted? This is again a Norris type 2 reaction. Norris type 2 reaction means if we are considering this as a carbonyl compound, this is alpha carbon, this is beta carbon, and this is the gamma carbon. So gamma hydrogen containing carbonyl compounds undergo Norris type 2 cleavages. So that means the hydrogen present here is moved from hydrogen obstruction from here to here. So that means there will be a ring formation like this. What is the ring? 1, 2, 3, 4, four-membered ring formation with an alcohol. So this structure is nothing but this one, and this undergo further changes. What is the changes? Again, cleavage. So what is that cleavage? Both there will be a removal of ketene. Ketene means CH2 double bond CO is the leaving group. It will go and formation of double bond. So then obtained one is enol. Enol on keto-enol tautomerism, it will give you cyclo octanone. So overall, in this process, the involvement of Norris type 2 reaction and the elimination of ketene, CH2CO is the ketene, it is eliminated. And here I am taking one more unsymmetrical ketone. This on irradiation with the light, there would be a cleavage here, and alpha cleavage means you can consider that it is a Norris type 1 reaction, and you can write the product. So I will go to the next slide. In the next slide, I am taking a alpha beta unsaturated ketone, a cyclic ketone, alpha beta unsaturated cyclic ketone. This on irradiation, it will give you two products, two bicyclic compounds. What is the difference between these two? This is a cis substituted bicyclic compound, and this will be the trans substituted product. And if you are looking at the mechanism, alpha beta unsaturated cyclic ketone on irradiation with the lambda max of this carbonyl compound obtained singlet 1. Singlet 1 crosses the intersystem crossing, forming a triplet 1. So in this triplet, now it will undergo cleavage, homolytic cleavage. That means this pi electron is cleaved and the pi electron of carbonyl carbon is cleaved. Then what is obtained? Obtained one is a new pi bond formation between the carbonyl carbon and the alpha carbon, and there is an electron on the oxygen and the electron on the beta carbon. So then what will happen? The movement of electron from the carbon to oxygen. So once the movement of electron from the carbon to oxygen, that leads to a formation of carbocation. Then the adjacent phenyl group is migrated from fourth carbon atom to third carbon atom. This leads to a carbocation formation at the fourth carbon atom. Then the anion O- will come over here, and there will be a new bond formation between the second carbon and the fourth carbon. That's nothing but a bicyclic compound formation. So the obtained compound is nothing but this one. That means this is a cis one. Cis one will be the major compared to the trans one. This is about the mechanism how an alpha beta unsaturated carbonyl compound when it is irradiated. When it is irradiated. Right. I will go to the next slide. Here, I'm taking another alpha beta unsaturated carbonyl compound, which on irradiation. Which on irradiation. Hello. I'm in class. I'm in class, right? Okay. This cyanobenzene is migrated from here to here. So this carbon, and there will be cyclopropane ring formation from this carbon to this carbon. This is the one. That's how a product is obtained. Now, same pi bond migration, it's also possible in steroidal moiety. This is again steroidal moiety, more particularly sterol, we can call it as. So then when it is irradiated, pi electron and the carbonyl electron cleave. Okay, the obtained ones are. So obtained ones are what the obtained means this electron and this electron forms a new pi bond, and one electron on this carbon, third carbon atom, and one electron on the oxygen. That's what the obtained one. Now there will be a movement of this electron, third carbon electron to the oxygen. If the electron is moved from this carbon to oxygen, then this carbon attains a positive charge. Then that time the fifth carbon, the bond, fifth carbon atom bond, that means this bond is migrated from this carbon to this carbon. That means ring contraction, conversion of the 6-membered ring to 5-membered ring is occurred. Then there will be a positive charge on this carbon. Then what will happen? The anion, when it is coming here, this there will be a new bond formation between this carbon, okay, second carbon, and the sixth carbon atom. That is nothing but a product formation. So with this, I will go to the next slide. In the next slide, I am taking few more examples of pi bond migration. Photochemistry of 4,4. That means previously we had taken only mono substituted at the fourth position. Now a di substituted at the fourth position, alpha beta unsaturated carbonyl compound. Here R may be an alkyl group or aryl group. That means photochemistry of 4,4 di substituted cyclohexanones and cyclohexadienones. Okay, here hexanones I'm taking. In the future slides, I'm taking hexadienones. So here R may be alkyl group or aryl group. Then what will happen? This is again a example. These are general one and these are examples. And then here I am taking this on irradiation. This on irradiation, tertiary butanol, okay, is the solvent used. Then it will go to a singlet and then triplet, and then migration of this methyl group to this carbon. There will be a tricyclic moiety formation between this carbon and this carbon. That is the product, and this is the 95% yield one. 95% yield one will be the migration of methyl group from the fourth carbon atom to third carbon atom. One will be the major one. Other one is the 5% product formation. So let's go to the next slide. In the next slide, I'm taking about the mechanism, how the previous product is formed. So dimethyl, 4,4-dimethyl, alpha beta unsaturated cyclohexanone. When it is irradiated with the lambda max of this one, forming a singlet, singlet one crosses the intersystem crossing and forming a triplet one. And the triplet one, the pi electron and the carbonyl pi electrons are cleaved, forming a new pi bond and leading to a 2 radical at the third carbon atom and the oxygen atom. Then there will be a movement of the third carbon electron to the oxygen that leads to a positive charge on the third carbon atom, and there will be a movement of the methyl group present in a fourth carbon atom to third carbon atom, and then this leads to a positive charge on the fourth carbon atom. Then the anion present on the oxygen will form a double bond, and then movement of the pi electron that leads to a 3-membered ring formation. And this is nothing but a required product, that is 95% yield one. And the other one, what is that? Other one, it is formed a 5% one, non-cyclic one. With this, I will go to the next slide. In the next slide also, I am taking few more examples. But here, the examples are cyclohexadiene ones. Previous ones are cyclohexadiene. Hexe means one double bond containing one. But here, 2 double bond containing one. So this 2 double bond containing one will lead to the formation of aromatic compounds. That is the advantage. This is also called as dipi methane one. This is the dipi one. My pi bond migration, 2 pi bonds are involved, and those leads to a aromatic compounds. So here 4,4 diphenyl cyclohexadienones on irradiation, gives you a bicyclic compound. This bicyclic compounds further irradiation in presence of aqueous dioxide solvent one gives aromatic compound in addition to a long chain carboxylic acid, alpha beta unsaturated carbonyl compound. So you can also observe that here gem phenyl groups are there, whereas in the product it is distributed. That means second and third methyl groups. That means right here third and fourth phenyl groups are there. That's the difference between these two products. So here I'm taking one more example. This is again this reaction or photochemical reaction carried out in aqueous dioxane solvent system 1. The products are like this. So, right. I will go to the next slide. So here I'm taking the mechanism dipyl. So 4,4 disubstituted cyclohexadiene on irradiation with the carbonyl lambda max. It will go to a singlet, and the singlet one crosses the intersystem crossing, forming a triplet one. And the triplet in the triplet, pi bond undergoes cleavage, and the carbonyl pi bond undergoes cleavage, forming a new pi bond and the two electrons at the oxygen and the third carbon atom. So from here to here, there will be a movement of third carbon atom electron to the oxygen. This leads to a positive charge on the third carbon atom. Then there will be a migration of this bond, carbon bond to this carbon. That means C4, C6 migration, forming a intermediate like this. And then anion will come over here. The pi bond will come over here. That is nothing but a required product. In the next slide, I am taking the mechanism how a bicyclic compound is converted into a aromatic compound. So here, this on further irradiation with the light, a singlet is obtained. Singlet on intersystem crossing, forming a bicyclic compound. And this bicyclic one undergoes homolysis, pi electron homolysis and carbonyl oxygen pi bond homolysis. So forming a new pi bond. This is the new pi bond, and the two radical at carbon 3 and carbon oxygen 1 on the oxygen and the carbon 3. Then what will happen? This cyclopropane bond cleavage. That means that leads to a new bond formation here. Then there will be a radical formation on the this carbon atom, and also there is a radical on the oxygen. Then alpha carbon radical is moved from carbon to oxygen. That leads to a formation of positive charge on the alpha carbon. Then there will be a migration of phenyl group 1,2 migration that leads to a formation of positive charge on this carbon. Then that time O minus will come, means O minus forming a ketone 1 pi bond movement. This leads to a formation of ketone, and then loss of proton forming a phenol, more particularly 2,3 diphenyl as the product. This is about the mechanism how a 4,4 disubstituted cyclohexadienes are converted into aromatic compound. With this, I will go to the next slide. In the next slide, I'm taking how a 3,4 substituted product is obtained by taking an intermediate 1. And here, suppose if the biphenyl group is not migrating, then what will happen? Instead of that, if there is a movement of pi bond in a benzene, then what will happen? There will be a positive charge on the fourth carbon atom. Then in such case, if the phenyl is migrated from third carbon atom to fourth carbon atom, then there is a positive charge like this. Then O minus will come over here and this pi bond will migrate here. So forming a fourth position ketone, and then fourth position hydrogen proton will be lost. So forming a product. The product is 3,4 disubstituted phenol. So with this, I will go to the next slide. In the next slide, I'm taking how a aliphatic compound in place instead of aromatic, how the aliphatic compound is obtained. More particularly, alpha beta unsaturated. Not only alpha, beta gamma, alpha beta unsaturated carbonyl compound is obtained. So by taking the intermediate, this is an irradiation, singlet is obtained, and then pi bond and the carbonyl pi bond cleavage, forming a radical on the third carbon atom and the oxygen. And instead of breakage on this carbon, if it is a breakage between the phenyl carbon, means benzylic carbon, and the fourth carbon atom, in such case, there is a formation of intermediate like this, and then the movement of electron from the carbon to oxygen, then the obtained one is this intermediate, and this pi bond will come over here. This pi bond will come. This pi bond is coming, this bond breaks, means formation of double bond, and the obtained one is this. A ketene is obtained. This ketene on reaction with water, a carboxylic acid is obtained. This is nothing but a prismatic. Then with this, I will go to the next slide. In the next slide, I am taking naphtho. This is a tetralone, okay? Tetralone derivative. This also a tetralone. If this is irradiated in presence of methanol, it will give you naphthalene compound. Naphthalene, more particularly naphthal, one naphthal derivatives. 2,3 diphenyl 1 naphthal, 3,4 diphenyl 1 naphthal are the products. Suppose in place of phenyl 4,4 diphenyl, if there is a one of the phenyl is replaced with the CH3, in such case, phenyl will be migrating from the fourth carbon atom to third carbon atom, not the CH3, when this reaction is irradiated in methanol. I will go to the next slide. In the next slide, I am taking few more examples. Here, cyanobenzene 1 and benzene means phenyl and cyanobenzene. If these two are the substituent, then the products are cyanobenzene will be migrated from fourth carbon atom to third carbon atom. Okay, right. Then means it's a major. Major one will be the movement of cyanobenzene. Minor one will be movement of phenyl group. So let us take one more example, a important one, more particularly. You can say that a bicyclic compound having 2 pi bonds, when it is irradiated, more particularly in the solvent, this is tertiary butanol as the solvent. This one is converted into tetraline, hydroxytetraline. These two are the products. Then I will take one intermediate. This intermediate on irradiation, a bicyclic bond, bicyclic moiety on irradiation, it will give you a phenol, paracymene phenol 1. How this is obtained? Let's look into the mechanism. On irradiation, this carbonyl pi bond homolytic cleavage and the 3-membered carbon-carbon cleavage forming a radical on the fourth carbon atom and the oxygen. Then this radical is moved from fourth carbon atom to oxygen, Then there will be a migration of, then there is a loss of proton. Proton is lost, forming a aromatic compound. With this, I will go to the next slide. In the next slide, I am taking photochemistry of olefins. Okay, photochemistry of olefins means double bond. Double bond means maybe conjugated or non-conjugated. And as we are aware that these olefins are insufficient at crossing the intersystem crossing, and therefore in direct irradiation, the products are 5 to 5 star excited state. It is possible to use the sensitizer, means photosensitizer. In such case, 5 to 5 star triplet will be the excited state. On direct irradiation, 5 to 5 star singlet will be the excited state. Then olefins undergo following types of reactions: intramolecular crossed addition reaction, simple addition reaction, and photocyclodimerization, photocyclo-addition reaction, geometrical isomerism or cis-trans isomerism are possible from the olefins. Let's take the first one, intramolecular crossed addition reaction. Both the singlet and the triplet excited states undergo intramolecular crossed addition reaction. Here are the few examples. So this is an alkane or olefin. So olefin on direct irradiation, the product is quadricyclone, quadricyclane, cyclone. And then even if the olefin is irradiated in presence of triplet sensor also, triplet sensitizer also, the product is quadricyclane. Then if we are looking at the mechanism, a ground state olefin or bornene, and this on direct irradiation, it will give you the singlet. Singlet means singlet on irradiation with the triplet sensitizer, then it will go to, this is the singlet structure. Singlet structure should be opposite spin. So you need to change this spin if it is a singlet one. Actually, according to this spin, it is a triplet one. Then you can observe that here moment means this pi bond cleavage means then electrons in terms of opposite one, singlet one, these are also opposite, singlet one, and there will be a new bond formation between this carbon and this carbon, this carbon and this carbon. This is how quadricyclane is obtained. I will go to the next slide. In the next slide, I am taking narborneol, means acetoxy-narbornene. This on irradiation, it will give you a quadricycline acetoxy 1. Here I am taking one more example. This is again a natural product intermediate. So it contains 3 pi bonds. So it is possible to get a different 2 or 3 products. This is again alpha phenene. This is an alpha phenene. And this on when we are using triplet sensitizer, if I remember, a bicyclic compound is obtained. When we are direct irradiation, we'll get a 4-membered ring. So the direct irradiation product is possible between these two. Okay, and then triplet sensitizer one is possible between this pi bond and this pi bond. Anyway, we are looking at the mechanism of these 3 products, how these 3 products are obtained. That mechanism we are discussing in the next slides. Here I am taking one more example. A bicyclic compound is obtained. And here is the mechanism how the 3 products are obtained. So between, you know that this cis-trans one on irradiation gives the cis one. So cis 2 plus 2 pi cycloaddition forming a 1 product. And the mechanism for the alpha phenene one. So there will be this pi bond and this pi bond undergoes homolytic cleavage, forming a transition state like this. Then bond formation, the obtained is alpha pinene 1. I will go to the next slide. In the next slide, I am taking a mechanism how a bicyclic compound is obtained. And this is the triplet one. If this is the triplet, we can rewrite the structure as like this. That means this pi bond we are writing like this. And then this pi bond homolytic cleavage, this pi bond homolytic cleavage. So forming a one electron means triplet one. This is the triplet one, and this is the singlet one. So then there is a bond formation between these two electron, and these two electron bond formation is not possible. And then spin changes. After the spin changes, the bond formation is possible. Then, so here you know that it is a adduct. More particularly, norbornene and cyclopentadiene adduct 4+2 adduct. This also further undergoes 2+2 pi electron cycloaddition in presence of photochemical condition by using acetone as a triplet sensor. Then there will be a new bond formation between this carbon and this carbon, this carbon and this carbon. That's what the product. So with this, I will go to the next slide. In the next slide, I'm taking simple addition of olefins. This simple addition of olefins similar to the thermal simple additions. Olefins undergo simple additions with water, alcohol, acetic acid, etc. in light. So this follows the Markovnikov rule, proceeds via carbocation intermediate. Common triplet sensitizer can be used. The common triplet sensitizers are benzene, toluene, xylene. Marconic addition means more substituted anion part will be added to the more substituted carbon. That's called the Marconic addition. So here I am taking an alkane. Alkane on irradiation, methanol is used as a solvent, and xylene is a triplet sensitizer. The obtained product is methoxy methyl cyclohexane. How this product is obtained? That mechanism is here. 1-methyl cyclohexene on irradiation with the xylene, the obtained triplet one captures a proton, so forming a tertiary carbocation. To this tertiary carbocation, methoxy anion form a bond with this. The obtained compound is gem methyl and methoxy 1. With this, I will go to the next slide. Here I am taking, in place of methanol, I am taking the acetic acid. So then also, alkene substituted one, when it is in acetic acid on irradiation, xylene is the common triplet sensitizer. Obtained is acetoxy methyl cyclohexane. So there is an evidence for the carbocation intermediate. So this reaction follows the carbocation. Since there is a formation of carbocation, then these are the evidence for the rearranged product. Rearranged products are the evidence for the carbocation formation. So that means this is again a steroidal intermediate. This on irradiation in presence of methanol. The obtained one is methoxy at the ring junction. The formation of methoxy at the ring junction. So before attack of methoxy at the ring junction, it is possible for the migration of this adjacent methyl group. That's the product are these two. These two products indicates that there is a formation of carbocation. Then I will go to the next slide. The next slide, rearranged product indicates the formation of carbocation. Here also we are discussing the mechanism of rearrangement. So that means once the positive charge is formed here, the methyl group is migrated, 1-2 migration, migrated from this carbon to this carbon. Positive charge is on this carbon. Then there is a loss of proton. and forming a pi bond. So similarly, suppose if this proton is not lost, then CH3 proton is lost, then exocyclic double bond is the product. So here I am taking a still bean in presence of ethanol and toluene. This on irradiation, it will give you ethanol at the alpha position. Similarly, I am taking one more alkene when it is treated with methanol in xylene. Xylene is a sensitizer. Then the obtained one methanol will form a bond here. This is the one. So what it means in all this case, addition. What is addition? Methoxy is added to more substituted carbon atom. Hydrogen will be added to less substituted carbon. Here also. With this, I will go to the next slide. In the next slide, I am taking photocyclodimerization. So photocyclodimerization means reaction of 2 pi 1. So that means olefins undergo dimerization, produces cyclobutane derivative as the product in the light excited state. So what are the excited state? Pi 2 pi star 1 singlet, pi 2 pi star triplet are the excited state, that is direct or indirect one. And here pi 2 pi star additions are concerted reactions, and pi 2 pi star triplet additions are radical intermediates. So this on dimerization, butadiene and dimerization in presence of sunlight forming a product. What are the product? Here all are cis1. Here trans are there. 2 cis, 2 trans are there. This is cis, this is cis, and here trans, here trans. So 2 cis, 2 trans are there. Okay. I will go to the next slide. In the next slide, I'm taking a trans one I am taking. So trans on irradiation, it will give you the addition product. We can observe that trans here, this part is trans, this part is trans. If we are looking from this side, it's a cis one. If we are looking from this side, it's a cis one. If we are looking from this side trans, we are looking from this side is trans. This is again cinnamic acid. Cinnamic acid on irradiation with the light. The obtained products are 2 cis, 2 trans 1. This compound is also called as truxilic acid. And the orientation, these are the orientation for the product formation. That means new bond formation between this carbon and this carbon, this carbon and this carbon. New bond formation between this carbon and this carbon, this carbon and this carbon. Then this orientation will give you this product. This orientation will give you this product. So here I am taking cyclohexene. Cyclohexene on irradiation with light with the methanol as a solvent and xylene as a triplet sensitizer. The obtained compounds are the dimers, cyclobutane derivatives. I will go to the next slide. In the next slide, I am taking a substituted cyclohexene. Substituted cyclohexene on irradiation with light, more particularly methanol as a solvent, xylene as a triplet sensitizer. The obtained compound is methoxy methyl cyclohexane. Suppose indane, name of this compound is called indane. So indane is irradiated in presence of triplet sensitizer. A dimerization is occurred. The occurred one will be, there will be a new cyclobutane formation between this carbon and this carbon of the same carbon of the indane one. Then here I am taking a cyclopentene. Cyclopentene on irradiation with the triplet sensitizer. Cyclobutane derivative is obtained. So here I am norbornene. Norbornene on here sensitizers are different, acetone and the acetophenone. So the products are dimers, first and second. This is again diastereomeric of each other. Why diastereomeric each other? Because there is a formation of 4 chiral atom. That's the reason. And here we are explaining in terms of endo and exo. So endo and exo, that means 2 plus 2 endo formation and 2 plus 2 exo formation. So here this is an exo and this is also a hex, but ring junction is trans. And here exo and endo, the ring junction is trans. Okay, I will go to the next slide. The next slide I'm taking a aromatic compound, but there is a double bond. This double bond or olefin undergoes a dimerization in presence of sunlight in methanol, giving rise to this product. And this is again still been, more particularly trans still been on irradiation with light and